What's up? What's up? It's your man Jimmy Chan. All right, so we're talking about linear functions. So with linear functions, yes, we're talking about lines. Obviously, there are going to be slopes, right? So with this function right here, y equals mx plus b, we know that this is a slope-intercept form. With a slope-intercept form, we have a m, which is the slope. We have the b, which is the y-intercept. Of course, y-intercept is a point on the y-axis. Now, we also talked about before is that slope is the change in y over the change in x. So we had this formula here, y2 minus y1 over x2 minus x1. However, what if we put this into function notation? Well, we put in function notation, well, y has been known as f of x, right? So if this is y sub 2, which corresponds with x sub 2, then we're looking at f of x sub 2 minus f of x sub 1. So I'm still talking about the slope here, but the y just looks different. And we call this the average rate of change, all right? So obviously with lines, we can either be having a positive slope, a negative slope, or zero slope, right? So if we're going from left to right and the line is going up, we have a positive slope. And if it's going down, we have a negative slope. And if it's going to be horizontal, meaning what if we were skiing right here, right? We're going to look something like this, right? With the skis tucked under our shoulder. We're going to have zero fun here. So that's why the slope is 0. All right, oopsies. There we go. Sorry, dude. So those are the things that we have to remember. Now, if it's a vertical line, then we have undefined slope, because if we were skiing on that, which is skiing on the side of Grand Canyon, well, it would be a lot of screaming, and then probably an echo of splatter of your body on the grounds of the Grand Canyon, which is not going to be fun, because by the time they get to your body, it's probably going to be undefined. So therefore, that slope would be undefined. All right? So with linear functions, so anytime we're given a set of points and we're trying to figure out if it's linear or not linear, let's go ahead and do its slope so that we can figure that out, okay? So pick 2 points, find the slope. Pick another 2 points, and notice how I said the x1, y1, and I repeated that, and then pick a different second point and find that slope. If the 2 slopes are the same, then we're linear. If it's not, then we're going to be nonlinear. So let's take an example of this soda and dogs here, right? Now, a couple of ways you can do it. One is that you can see, let me blow this up. You guys can see that as the soda, let's see if this works. Okay, when the soda, right, goes down 5, what happens with the dogs? What happens with the dogs? What happens with the dogs? Right? It goes up 3. And we can do this again and say, okay, does this go down by 5 as well? And does this go up by 3 as well, right? So if you notice that it constantly does that. Right? So we could do it that way, but it doesn't always do that, right? Because what's going to happen is that majority of your points are going to do this type of thing, and then you're going to have one or two that's going to be out of whack, that's going to make it look like it's not linear, but it really is, because you have some of the points that are off. Because if we're going to do a scatter plot for the best fit line, well, majority of those points are going to be on that line, and a couple of them are going to be outside of it, okay? And this is an example of that everything works out pretty well. So let's go ahead and leave that example right there. And bring this down so that we can see a different kind of example of what I just showed up there. So let's say I pick this point right here, and I pick this point right here. Okay. So here, what I have is, if I took the change in y over the change in x, then I have 0 minus 3 over 20 minus 15. So my slope here is negative 3 over, oopsies, 5. So negative 3/5, right? Now, what if I took the same one, but then I'm going to take a different point, right? Which is the 10/6. So when I do the slope here, what do I get? I get still the 0 minus 6 over the 20 minus 10. Okay, so if that's the case, let's take a look. I get a negative 6 over 10. Well, what does that reduce to? That reduces to negative 3 over 5. So if you notice that my two slopes are the same, so therefore these sets of points are going to be linear. Okay? All right. Actually, let's go ahead and box this up. And there we go. All right. All right, let's continue on. So if we were to model for it, essentially what it's asking us to do is find the line or the equation of the line of those points, right? And don't forget, this is just the slope-intercept form, but we also have another form. So this is the slope-intercept form, so this is called the SIF, but we also have the point-slope form, which is y minus y1 is equal to m times x minus x1. Okie doke. All right, so let's compare two lines when they're given to us, right? So let's say that we're talking about supply and demand, and the supply came up with an equation of negative 250 plus 50p, and the demand came up with it as 1,000 minus 75p. So number one, when we look at the slope and we compare it to the line that we see here, right, we should know which one is which, all right? So this is the y-intercept because it's the number that stands by itself. So that's a y-intercept. And the slope here is positive, so meaning going from left to right, it's going to go up. So this here must be my supply, S of P. While going from left to right, this is going downward, so let's take a look at demand, if that's true. Well, first of all, the y-intercept is 1,000, so this seems like it's going to go up towards 1,000 when it hits the y-axis. And then the slope is negative 75p, so, or negative 75, so I know that this blue line must be my demand. Okay? So as we're looking at this, a couple of things I want you guys to see though, okay? So if you look at this piece right here, let me go and just draw the box. I'm sure it's not going to be awesome by any means, but from here to here, right, inside this box. So let me go ahead and zoom in right here, right, and bring it over here. Whoa, that's not what I want to do. I want to do that. Okay, so if I look at this right here, what you notice is that the blue line is above the red line, okay? So in this side of where they intersect, let me do it this way. So the blue line is above. So what this is telling me is that the demand is greater than the supply, right? Now, if I look at on this end, right, you see that the red line is above the blue line. So that tells me that the supply is greater than the demand. Or better yet, we should probably write it as that the demand is less than the supply. Okay, so instead of it this way, let's keep it consistent with the other side that we already wrote. Oopsies, not what I want to do, right? So that's what we want to make sure that we do, all right? So let's delete that. So question is, if to the left side of where they intersect, demand is greater than the supply, but on the right side of that is where the demand is less than the supply, then what is that point in the middle? What that point in the middle would be considered the equilibrium point. Okay? And that is where the demand is going to equal to the supply. Okay, so that is where this point is. Okay, that point right there is the equilibrium point, which is where the demand is equal to, come on, click in the spot there. There you go. All right, so that's the equilibrium point where the demand is equal to the supply. So here we can say that the demand is greater than the supply along the intervals of, well, let me see, how do I want to throw this at you? Because I don't know if the demand is ever going to be negative or the supply is going to ever be negative, because that means it's before production, right? So let's say that the demand is going to be greater than the supply from, actually, we're going to have to go from 5 to 10, right? Because I'm looking at the X values, and that's why I'm using 5, because I don't think I can have negative supply, right? So I'm going from 5 to 10, and that is the point where the demand is much higher than, the demand is much higher than the supply. Where this right here would be, again, I can't have the demand go negative, so that's 13 something. So I guess I'm going to have to do it this way, because it is going to go past 13, and I don't know if that is not quite 13.5. So let's just put it down as from 10. Actually, I can't even use a 10 here as I have to close it. So from 10 to, let's say, 13.25, right? So that's what we will have to say, right? In terms of the interval that the demand is greater than supply or the demand is less than the supply, okay? So anyways, about the equilibrium point. So the question is, what is the price for the equilibrium point? And as you guys see, that once I wrote this, I wrote down what the P stood for, what the S stood for, and what the D stood for, right? So that this way I know exactly what the heck I'm talking about. Well, to find this equilibrium point, since these two are equal to each other, that's the equation that I would actually write. That negative 250 plus 50p is going to equal to 1,000 minus 75p, okay? So from there, let's go ahead and solve for p, because p is the only thing there, all right? So if I was to, let me see here, how do I want to do this? I want to add the 75p over, so what is that, 125p? I'm going to add the 1250 over, so that's going to be what, 1250? And I got divide, so the p is going to equal to 10, okay? So now I know at the price of $10 is when they will be equal to each other. But again, this will also show me that to the left of 10, the demand is going to be greater than the supply, and to the right of 10, the demand is going to be less than the supply, okay? So the question is, how many shirts Oh, I'm sorry. Yeah, if this was supply of shirts, let's say, right? A popular shirt, what how many shirts would that need to supply to meet the demand? Well, what you guys can do then is just to find the supply of P, or better yet, since I already know this amount is 10, which is negative 250, plus 50 times 10. So that supply of shirts is going to be 250 shirts. Okay, and this is going to be $10. And if I was to look at the demand should be exactly the same of the 250 shirts. So let's go ahead and take a look. So if I look at not the P of, the D of 10, that is equal to 1,000 minus 75 times 10. Yep, D of 10 is also equal to 250 shirts. And there we go. Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.